Alright, in this video, we want to prove that if S equaling V1, V2, V3, or the set that contains V1, V2, and V sub 3 is a basis for the vector space V, then T equal W1, W2, W3, where W1 is equal to V1 plus V2 plus V3, and W2 is equal to V2 plus V3, and W3 is V3, that is also a basis. So to show that any set is a basis, we need to show that this set is linearly independent and it spans the vector space. So let us look at a linearly independent, let's look at a linear combination of vectors of W1. Say C1, W1 plus C2, W2 plus C3, W3, and let's set it equal to 0. If those coefficients must be 0, then W1, then set T is linearly independent. But this is the same as C1 times W1, which is V1 plus V2 plus V3, plus C2 times V2, W2, which is V2 plus V3, plus C3 times W3, which is just V3. And this equals 0. Okay, distributing the C1, get C1 V1 plus C2 V2, C1 V2 plus C1 V3 plus, now I distribute the C2 to V2 and to V3. And let's not forget to add on the C3 V3. And this is still 0. Now let's collect the V1s and the V2s and the V3s. We have C1 V1 plus, when it comes to V2s, we have C1 plus C2 V2s. And when it comes to V3s, we have C1 plus C2 plus C3. V3 equals 0. But this linear combination, which is the same as this one, just written differently, is a scalar times V1 plus a scalar times V2 plus a scalar times V3. Since, let's just say S. Since S is a linearly independent set, the coefficient C1 must equal to C1 plus C2, which must equal to C1 plus C2 plus C3 is 0. So C1 is 0. But now we just have the domino effect. So C1 plus C2 is equal to 0 plus C2, which is C2, and it too equals 0. C1 plus C2 equals 0. That means C2 is 0. Now, if C1 plus C2 plus C3 equals 0, but we just learned that C1 is 0, plus C2 is 0, plus C3, this sum, not only does it equal to 0, but it equals to C3. Okay, hence, where are we? Hence, this original set, hence T, which was W1, W2, W3, is a linearly independent set. So we have half of it. Took a lot of writing, but we have it. Nothing complicated even. Okay, Now we want to show that it spans. Okay, so let V be a member of V. Since S is a basis for V, S also spans V. That is, there exists C1, C2, and C3, such that V is equal to C1 V1 plus C2 V2 plus C3 V3. Okay. Now, what do I want? I want that V is, say, K times W1, K1 W1 plus K2 W2 plus K3 W3, where W1, let me just be sure, W1 is the sum of all three. So we have W1 plus W2 plus W3 plus K2, V1, V2, V3 plus K2 is, W2 is V2 plus V3, and W3 is just W3. So this is K1 V1 plus K1 plus K2 V2 plus K1 plus K2 plus K3 V3. Now let's see. Let us call that K1. Now, C2 is just a real number. So there's and K1's a real number. There's something to add to K1 to get to C2. Call it K2. I mean, if C2 is 7 and K1 is 3, there's something to add to 3 to get to 7. It's called 4. Okay, now C3, I can start off adding any two numbers, and there's something that I can add to it to get to K3. Okay, so that down there helped us. Certainly helped me. Sometimes you should look at what you want. So now I just want to see something. Maybe I really did that backwards. Okay. So this becomes K1 W1 plus K1 times V2 plus K1 times V3. Let's hold on to that. Plus K2 times V2 plus K2 times V3 plus K2 times V3 plus K3 V3. So this becomes K1 times, I'm factoring out the K1, becomes K1 times V1 plus V2 plus V3 plus I factor out the K2 This is V2 plus V3, and this is just K3 V3. Okay, this equals to K1. Now that, by definition, was W1 plus K2. By definition, that was W2 plus K3 times, well, by definition, V3 was W3. So you know what? I was able to write an arbitrary vector in V as a linear combination of vectors in W. Okay, so I think your T spans the vector space. And we wanted to show that T is a basis. So putting these two pieces together, the fact that T spans V and that T is a linearly independent set, we conclude that T is a basis for V by definition. I showed that T is a linearly independent set in V and that T spans V. Hence, T is a basis for V. If you love videos like this, please subscribe to my channel. All we do here are mathematical proofs. If you have a proof that you're dying to see, just leave it in the comment section and I will try to prove it. See you guys in the next video. Watch and learn.